Hello, friends of Euclid. We're here to talk today about Lesson 2-2, Definitions, and why definitions are important in geometry and how they are created in geometry. Alright, so you can see that this young boy here, he's got what they call the Davy Crockett haircut. And here's a conditional statement. If you have a funny haircut, then people notice you. So you can see that this is the hypothesis, and this is the conclusion. How do you identify where they are? You look for the keywords if and then. Okay? If identifies the location of the hypothesis most of the time, or some word like that, and then identifies the conclusion, the location of the conclusion. Alright, now what has been done here in the second statement, we have exchanged, we've taken the conclusion and put it in the place of the hypothesis. And we've taken the hypothesis and put it in the place of the conclusion. So we have changed them around. This is called converse. Alright, so let's take a look at another situation here. We start with a conditional statement here. We take a conditional statement and its converse. And as we saw yesterday in the lesson, in 2-1, just because a conditional statement is true does not mean its converse is going to be true. But if we're going to make a definition, then the conditional statement and its converse that go together to make the definition both have to be true. So let's start with this. Here's a conditional statement. If a figure is a triangle, then it is a polygon that has 3 sides. Alright, if a figure is a triangle, then it is a polygon that has 3 sides. And we would say that's true, yes. Now where's the hypothesis? We look for our keyword if, and we see it identifies where the hypothesis is. And that we call A. Alright, and where is the conclusion? We see that the keyword then helped us find the conclusion. There's a polygon that has 3 sides. So that we call B. And symbolically, we can represent this way. And we say that if A, then B. Alright, you remember learning that in lesson 2-1 on conditional statements. Alright. How would we write the converse of this statement? We've already identified that this conditional statement is true. How do we write the converse? Okay, we have the hypothesis and conclusion change places. So in other words, we have B and A change places. So if B, then A. That's how we represent it symbolically. Is this one true? If a figure is a polygon that has 3 sides, then it is a triangle. That has 3 sides, then it is a triangle. Yes, that's also true. Okay, so we could put these two conditional statements together to make a definition, because what we have here is the hypothesis and the conclusion mean the same thing in either case. Figure is a triangle. Okay, the word triangle means the same thing as polygon that has 3 sides. And for that reason, they're both true, and we can put it together to make a definition. Alright, so how? Alright, what's this say? A figure is a triangle if and only if it is a polygon that has 3 sides. So we've taken both of these parts and put them together, separated by the words if and only if. And that's how we make a definition out of 2 conditional statements. One is the converse of the other, and they both have to be true. Symbolically, we have a little bit more to introduce to you here. This IFF is one of the ways we can write if and only if. Alright, or we can write this. Notice the difference between that's array. This is looks more like a line, so that means it goes in both directions. Alright, so A if and only if B is how we would say that. And that is an example of how we take two conditional statements, one the converse of the other, both have to be true, and turn them into a definition. Now, so what should you know from this particular lesson? This is the main points that you should get out of this lesson. Number one, consider this conditional statement. If a figure is a triangle, then it is a polygon that has three sides. Write the converse. If a figure is a polygon that has three sides, then it is a triangle. Using symbols, write the converse of the symbolic statement below. If A, then B. Converse means that A and B switch places. So if B, then A. What is the meaning of this symbol? If and only if. Combine the conditional statements from one with its converse to give the definition for a triangle. A figure is a triangle if and only if it is a polygon that has three sides. Okay, so keep this all in mind as we read the lesson and do the homework from that. And that's all for lesson 2-2, definitions.